We'll start today by looking at prime factorization. Remember that a factor is any value that you multiply to gain a product, and that prime numbers are any numbers that can only be divided by themselves and 1. So if we're looking for prime factorization of a number, that means that we're looking for all of the prime numbers that you multiply together to get this value. So the number we've got right now is 924. What I always tell people to do is check the first 5 prime numbers: 2, 3, 5, 7, and 11 for divisibility. Sometimes you have to extend to 13 and 17. One of the first clues is to look for things like even numbers, something that's divisible by 5 or by 2. Those are really easy to see. To test if something is divisible by 3, you just have to add up your values. So this would be 9 plus 6, which is 15, and 15 is divisible by 3. So this is divisible by 3 also. So those are just some clues that you can look for. This value here, 924, I know it's an even number. I make it sort of into a factor tree, and I say that this is 2 times 462. 462 is another even number, so this 2 stays here, and this becomes 2 times 231. I have no more even numbers, so I can check to see if this is divisible by 3. Since this should be 2 plus 3 plus 1 is 6, so I can divide this by 3. And when I do, this 2 stays the same, that 2 stays the same. This becomes 3 times 77. And then I know that 77 is 7 times 11. I strongly recommend that when you're doing prime factorization, you organize the factors from smallest to largest so that you can see what's happening. Prime factorization really is the first step in finding the greatest common factor of values and least common multiple of values. Before we go into a lot of detail what those things are, let's get prime factorizations of the 3 numbers we have. So we are finding both greatest common factor and least common multiple for these values. So for 100, if I get the prime factorization, I know that 100 is 10 times 10, so that makes this 2 times 2 times 5 times 5. For 120, I know that 120 is 12 times 10, so that becomes 2 times 2 times 2 times 3 times 5. And then finally I've got 90. That's 9 times 10, 2 times 3 times 3 times 5. For greatest common factor, what I'm going to do is I'm going to look for values that show up in both, or not both, in all 3 numbers. So I have a 2. So I write down 2. What you notice is that you do not have that second 2 here. So you can't count a second 2. We don't have a third 2 in either one of these places. If you look here for the 3, you've got a 3 in 2 of them, but not in this one here. So you can't count that 3. The next value that exists in all 3 is a single 5. So the greatest common factor, that means it's the largest number that you can divide 100 by, 120 by, and 90 by. I can do 100 divided by 10, 120 divided by 10, and 90 divided by 10. Least common multiple is a little bit harder. What I do with least common multiple is I take my first set of prime values and I list them out. And then I go to my next set of prime values, and I cross out anything that's been used. So I've got a 2 here, and I have a 2 here, so I can cross out a 2. I've got a second 2 here, so I can cross out a second 2 there. But notice I don't have a third 2 here. There are 3 2's here, which means that I need 3 2's over here. So I will add that in. Then I look, there's a 3. Do I have a 3? There are no 3's, so I need to include a 3. And then there's a 5. I've got a single 5 here, which means I can't replace that 1 5. Now I've finished with the factors of 120. I move on to the factors of 90, and I start from the beginning. So there's a 2, here's a 2. I have to cross out one of these 2's. There's a 3, I've got a 3, so I have to cross out the 3. Here's a second 3. There is no second 3 listed over here, so I have to include that. Then I go back, I've got a 5, here's a 5. This is why I tell you to list these values in order. So now, this is the prime factorization for the least common multiple, and this value is 1800. This is the smallest number that I can divide by 100. So I can do 1800 divided by 100, 1800 divided by 1200, 1800 divided by 90. We can do the exact same thing even when there are variables. So on the first one, prime factorization of 32, that's 2 to the 5th power. There are 3 x's and 3 y's. For 120, I know that that is 3 2's, a 3, and a 5. I've got a single x and 4 y's. And then for 42, oh, I should have included that this was xy to the 4th. For 42, x squared, y cubed. 42, that's 7 times 6, so that gives me 2 times 3 times 7, 2 x's and 3 y's. And then I go through the exact same process. For greatest common factor, I find all the things that they have the same. So here's a 2. There's another 2 here, but I don't have a second 2. I definitely don't have a third 2 or a fourth 2 or a fifth 2. So I'm done with all my 2's. If I move on to x's, I can see there's an x here. There's no second x going on here, so I can't use any of these. So I can move on to the y's. There's a y. That's 2 of them. 3 of them. So I have 3 y's. So what I can write down, I circled 2, x, and 3 y's. So that's 2x y cubed. Now I do least common multiple. So I'll write down the entire prime factorization for 32x cubed y cubed. And then I start. I've got 5 2's. 1, 2, don't have any more 2's, so I don't have to cross out 2's from 120. but I don't have any 3s, so I have to tack on a 3. I don't have any 5s, so I have to tack on a 5. But I do have 3 x's, so I have to cross out an x. And I do have 3 y's. 1, 2, 3. There's a 4th y right here, so I got to tack that onto the end. Now I move to the next one. There are 5 2's. There is 1 3. There's a 5, which I don't see here, but here's a 7, so I need to tack that on to the end as well. And then when I start looking at x's, again, I've got 3 x's here, so there are 3 x's, and I've got 4 y's, so 1, 2, 3. So now I'm done. And now I start to collect all these values. This is 35 times 15 times 7. I calculate that to be 3,360. I've got 3 x's here, so that's x cubed. And then I've got 3 plus 1 more y, that's y to the 4th.